we are going to start talking about this thing called Lewis dot structures. Lewis dot structures are extremely important because they talk about, or they give us a representation of what's happening to the electrons three-dimensionally in space when we make a bond. Okay, we start small. We start at the atom level, then we look at the bond, and then we go to the molecule. Okay, Lewis dot structures give a sense of 3D structure to these things we're representing on a piece of paper. So, getting to know how to draw a proper Lewis dot structure, first starting with an atom, then looking at ions, then looking at ionics, then looking at bonds where things are shared, and then a molecule, you get this building process which gets you to a point where you can look at a molecule and say, oh, when it's in space, it's going to have a certain shape. Okay, so it's really important to do Lewis dot structures. And what I'm going to show you is a couple of things. I'm going to show you a Lewis dot structure, and then I'm going to show you this website where you can start to put together things. And so you're going to have the note video to watch, but you're also going to have this video that you're going to play around with in terms of a website and putting things together. So let's go here. When we look at Lewis dot, again, we start with the atom first, and we're going to look at the Lewis dot for the atom. Then we're going to look at a bond, and we're going to start with ionic bonds and making ions. So we're going to start small with just an atom and then its corresponding ion. Then we're going to look at making a Lewis dot for bonds. Ionic is the simplest one to do because you can cheat. I'll put down here, you're going to cheat. The other thing that we're going to do is once we do this, so this is like our little baby step here, step one. Then we're going to go to a bigger step. Then we're going to go on to doing a whole molecule. And when we do the whole molecule, we're going to look at it as in 3D space. Right? We're going to have to try to represent it on a two-dimensional frame. So we represent it on paper, but we talk about its 3D space. Right, so we're going to start small. We're going to talk about what does it mean to do a Lewis dot of an atom. There is a particular order you go in when you do a Lewis dot of an atom. So this all stems from our electron filling. We fill the s first, right? So we did, here's our s orbital, we go up, down. Right? Then we go to the p orbital. So p orbital has the 3 lines. Sometimes I use circles, sometimes I use squared. Remember how we did up, up, up? And then we went back and we did down, down, down. Okay, so keep that in mind. When you do a Lewis dot diagram, and a lot of them are done already here, but I'll go through it again as you can see it, it has an order to it. This is a generic X, any symbol. A lot of times we just use the X and we say, oh, it's any symbol that's symbol X. You always put the first 2 electrons together. And remember, they can start at any side. So I'm going to say it starts down here. Electron 1 and electron 2 go together. That's this s orbital. This is S. Then I put an electron here, an electron here, an electron here. Ooh, look. It's up, up, up. And then I'm going to put an electron here, here, and here. That's not the greatest pink because that's a pencil pink. So I'm going to go back. Come on, you. And I'll use this pink, and that's a pen pink, and you'll see it better. Okay. So that's where this part, when you see this and you see this, you're like, why is she doing it so many ways? An atom spins in space. It has 3 dimensions. So you can start on any side because the spherical thing that you have in space can be all over the place. Because remember, we're talking about that three dimensions, and we have an atom, and then we have all the different types of shells that are there. But it doesn't just stay in one place. This is constantly rotating and flipping and rotating and flipping, rotating and flipping and moving and rotating and flipping, as well as moving around like in a velocity, let's say, in a direction. So your little electrons can be in this population in any angle, any coordinate, XYZ coordinate in space. So you can start on any side. So that's why we say you write the symbol, you look at how many valence it has. So remember valence. Group 1 has 1 valence. Group 2 has 2 valence. Group 13 has 3 valence. Group 14 has 4 valence. 15, 5, 16, 6, 17, 7, and 18, 8. Notice these are easy because the group they're in is in the valence. But if we look at the other two, what I would say to people is take the one and cover it up. Oh, now I have 3 valence. Cover this up. Cover that up. And notice, if you cover it up, this is the same number of valence. So sulfur has 6 valence. It's in group 16. Again, I can start on any side. I can start on the top. 2 together. 3, 4, 5, 6. This works best with gel pens. Right? A gel pen, so you just have to hit the top. You just dab it. You just go boop. And you get your pen. You don't have to sit there. If you don't have a gel pen, you have to sit there and circle it in. If you have a nice thick gel pen, you just go and you get your dot. You just hit your paper. Okay. You can do this with anything on it. If I wanted to do sodium, sodium's group 1. It has 1. If I wanted to do this with strontium, strontium's group 2. And the first 2 go together. I want aluminum's the one they always ask about the most. I'm trying to remember what's under aluminum. This is horrible. It's not gallium. Yeah. Gallium. I think it's gallium. Right? Should be group 13. So gallium would have 3. Now, the only one that's tricky, and we're going to talk about later, is carbon. Okay, carbon with not making any bonds just by itself is like this. When carbon goes to make bonds, it promotes an electron because it tells it it's doing a good job, and it does that. This is the only one that doesn't act exactly by these rules, and we'll see why later. Okay? Now, these are atoms. When you do an ion, you have to do the ion with its charge. So you have to remember, groups 16 and 17 and 18 will gain electrons. One, 2, and 13. Oh, sorry, not 18. I meant 15, 16, 17. That's bad, my part. 18 doesn't gain. They gain electrons. 1, 2, and 13 lose electrons, so they get positive ion. Right, so this makes this positive. This will make it negative. And group 14, it depends on what it's with. Okay, so keep that in mind. If we say what's the, and this was part of the atomic structure quiz, and the ones I looked at so far got it right, but I only did a real brief look. I have not graded the quiz yet. So sulfur gains 2 electrons, so it'll have a -2. So if you look at sulfur, and we look at its structure here, it's got empty spots, right? It's got an empty spot here, and it's got an empty spot here. So when it gains the electrons, and it goes from being sulfur to sulfur -2, you fill in the empty spots. So if I start by putting my electrons on the top, my empty spots are on the side. The whole important thing is, if you gain electrons for non-metals, you're going to have all 8 electrons around it and have a negative ion. For metals, metals lose their dots. This is really important. And they have no dots and a positive charge. Non-metals will gain all the electrons and they'll have a negative charge. Okay, so that's the difference between doing atoms and ions. When you go to look at the worksheets I'm going to have you do, and I'm just going to do a few of these here. Pardon me. We talked about aluminum, but I'm still going to do it. Let's do calcium, rubidium, there's not much to choose from, guys, because you're either group 1, group 2, or group 13. So we'll do sodium again. So if I'm going to do the atom, the atom, this is 3 valence. 1, 2, 3. My pen's not big enough. I'm going to make it wider so that all I have to do is hit the thing. Okay. Calcium. What? Where did they go? See, this is what happens, guys, when I do this. I touch the screen. I don't have my little gloves on, so I'll just rewrite it. Right? We had calcium. We had sodium. We did aluminum. We had rubidium. Barium. We haven't talked about barium yet. These are all metals. So, gosh darn it. Every time I touch, guys, it's going to do this now. If I want to do the Lewis dot, there's 2 for calcium. Sodium has 1. Aluminum has 3. Okay, could I draw aluminum this way? Why, certainly. Could I draw it starting on the bottom? Certainly. Rubidium, group 1. Barium, group 2. Now, if I go and make the ion, those electrons come off. Right? They leave. And I have calcium, put a bracket, 2+. It's different than just writing the ion, because we're doing Lewis dots. Sodium, put a bracket, because it's the ion, 1+ outside. You could just do plus. It's equivalent to this. Okay, but Lewis dot requires the brackets, right? Will they really dock you points? Not really. You know, the thing they'll look for is the number of dots in the proper charge. But technically, the Lewis dot requires the brackets. Okay. If I go to aluminum, it's a metal. All dots come off. 3+. Rubidium, metal. All dots come off. Plus. Barium, metal. All dots come off. I've lost 2 dots. It's a 2+. Okay, so metals lose the electrons. No dots for the ion. Make sure you put the brackets and a positive charge. Outside the bracket, by the way. Okay? So let's think about non-metals. I'm going to erase everything. So if you don't have it down, pause it. Let's look at non-metals. So in non-metals, we always gain the electrons to get to 8. So you gain enough electrons to make 8 dots. So oxygen. Oxygen starts with 6. I have empty spaces. I'm going to take those and I'll put new electrons where those empty spaces are. Okay, this is supposed to be an electron. So then I've gained 2 dots. I put the bracket. Oh yeah, we need brackets here. I've gained 2 dots, so I'm 2-. Right, fluorine. Fluorine is 7. 2 together. 4, 5, 6, 7. Oh, look, fluorine only has one empty space there. So if I go to make an ion with fluorine, no matter what I interact fluorine with, I'm cheating in my dot drawing. The reason why I'm cheating is I know as a nonmetal it will have all 8 dots. So I don't sit there and go, oh, because it has all 8 dots, I'm going to put the first 2 together, and then I'm going to do around the horn, and then I'm going to come back and put the next set around the horn. Right? That's what you should be doing, but I know I'm drawing an ion. I'm like, all right, save time, dot, 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 dot. And I know that this is just a minus because I only had one empty space. Let's do chlorine. First 2 together. 1, 2, 3, 4, 5, because chlorine has 7 valence electrons. So when it goes to make an ion, here's chlorine's original 7. And then I have to add 1. And now finish the bracket, and it's a minus. Okay. Sulfur, anything under oxygen will have 2. Anything under fluorine will have 1. Anything under nitrogen, I look at nitrogen, first 2 together. That was awful. 3, 4, 5. Oh, nitrogen has 3 empty spaces. 1, 2, 3. So if I'm going to make an ion with nitrogen, and I'm not even going to change the color of the dots, because all I know is I need 8 dots. And I put the 8 dots around and a minus. You should try, and it's actually -3 or 3 minus, either way. This is really the proper way to do it. You should try to make sure that they're legible on each side. Okay, if you have a thick pen, you get a little bit, like if I make this pen even thicker, okay, you get a little messy. Here's my N. I gotta try to make sure when I do it, I put them on the sides and I try to make it so that a person knows which side it's on. Okay? Alright, so that is atoms and ions. I'm going to move this down a little so you can see it. Okay. So we're going to focus on the thing that's on the top. How these move and switch has to do with this wonderful octet rule. Okay? You want to have atoms become ions so they have 8 electrons around them. We are filling their valence shell. Okay, filling the outer shell, filling the valence. You're getting a complete octet. Okay, this is key. For ionic with transfer of electrons. So remember, that is transfer of electrons. Okay, not sharing, transfer. Those are the easiest to write. So we're going to learn how to write those. I'm going to move this down a little so you can see it. Okay. As always, I am going to constantly from now on, since we've learned about bonding, say to you when you approach a problem, the very first question you should ask your own little brain is, what makes the bond I'm looking at? What makes it? Metal, non-metal, or 2 non-metals? It's the most important self-assessment question is stop brain and ask this question. What makes the bond? Because if you are here, you are definitely ionic. If you are over here, you are covalent. Another word for covalent, I'm going to introduce this now. You got to know this. We talked about it before. Is molecular. It's a molecule. Okay, covalent means molecule. Interchangeable. Synonymous with. Right, that's something big. If you have covalent, it is synonymous with molecular. Don't forget that. All right. Ionic compounds are the easiest thing in the world. I'm going to go through this, and then I'm going to give you examples. I'll give you a few examples. When we talk about doing ionic compounds, we are actually talking binary here. The simple binary. When you get into polyatomic, you've got to do two different ways of doing your, and I've never seen them ask this, two different ways of doing your Lewis dots. One part of the polyatomic has covalent bonds. So if you do a polyatomic, you're actually over in this area first, and then you do these two together because you make an ion. Right? That's if you do polyatomic. So to do ionic, you kind of like cheat. I always tell people cheat. Okay, cheat. You're not really cheating. Make your formula before you even try to do this. It makes it go faster. So all that stuff we did over the weekend, then you're like, oh my god, I'm so sick of formulas. This never ends. It never ends, people. Okay? So you gotta keep writing your formulas. So we're gonna now keep doing our little formulas. This is a aluminum sulfide. And looking at an aluminum sulfide, if I make aluminum sulfide, aluminum's 3+, sulfur's 2-. I crisscross. I need 2 aluminums and I need 3 of the sulfur. So I can cheat. Aluminum's metal, no dots. I put the little bracket with the aluminum. I put the 3+ on the outside and I go, I need 2 of them. Oh, I put the 2 in front. Coefficient. Your subscripts become coefficients when you're doing Lewis dots with ionics. Subscripts become coefficients when you do Lewis dots with your ionics. Right? So that's we're gonna pull that up. Let's erase everything. Let's make a little comment here. For ionics. Ooh, I have a big fat pen. Let me change my big fat pen. Maybe this one. Okay, subscripts become coefficients for the ions. For bracketed ions. Right, so let's do a few. Calcium oxide. Formula right first. Ca, 2+. Oxygen, 2-. Ooh, they add up to 0. So I'm going to rewrite them neatly. Oh, I only need 1 Ca and 1 O. Okay, Lewis dot. Ca, bracket, 2+. Oxygen, all 8 dots. And yes, me cheating. Shortcutting, 2-. Complete, done. That's it. Magnesium chloride. Try it. Pause the video. See if you can do it. Okay, so hopefully you know magnesium is a 2+. Second column. Chlorine is group 17, it's a minus. If I were to make my formula, I get this. So by doing the quick method, no dots, bracket around it, 2+. Chlorine, all 8 dots. And yes, again, I'm not doing them in order with a minus, but I need 2 of those. And I'm going to neaten up, that almost looks like a 4. Let me neaten that up a little. Okay, whoops. This is a 2+. Done. Trying to think of another good one. Aluminum oxide. Aluminum. Oxygen. And you might say, well, why don't you just write those like the way it is and then call it a day? because it has to be correct for the formula. You have to have a balance of charge. So I crisscross these because they don't add up to 0. Oh, I need aluminum. We said 3 plus, but I need 2 of them. Comes out as a subscript. Oxygen. Oh, wonderful. 8 dots. 2 minus, but I need 3 of them. Oh, there we go. I'm done. That's ionic. Wham bam. Done. Really simple. Don't make it more complicated than it is, guys. People like to sit there and say, well, show the movement of the electrons. You could, but most of the time, all they want is the final structure. They don't ask for the movement of electrons. And I'll be honest with you, I'm going to teach you the movement of electrons. You really want to move the electrons, let me know. I'll make a video. I'll post it under the video resources, and you can look at the movement of the electrons. But honestly, for ionic, this is all you need to know. Covalent becomes way more complicated, but not so much that you can't figure it out. So let's look at covalent. Covalent has steps. You have to know these steps. We're going to draw so many of them that you're going to start off with your piece of paper next to you, and you're going to read the steps and follow them along. And then you're going to be like, oh, I don't need the steps anymore next to me. I can just do this. Okay, I'm going to be honest with you. If you don't get to that point, you are going to struggle horribly on your AP exam. Because all of this stuff has to become ingrained to you in the AP exam. Right now, AP is adamant. Exams are going to be administered in person. Oh, you are not going to have your notes for that exam. So you have to start internalizing everything. So here's the thing. Start with your total number of valence electrons. Okay, let me reiterate that. Total number of valence electrons. Right? Everything that's made that makes the compound. You say, oh, how many valence does that one have? How many does this one have? And you get the total number. Okay. Then you draw what we call a skeleton structure. It's going to depend on what's there. 2 atoms, you draw them side by side with a space in between. 3 atoms, you got to look and see, is any of them in the center? Like, is there one of one kind and 2 of another? Draw whatever's going to be in the center, and put the other surrounding it with spaces in between. 4 atoms and 5 atoms, the same thing. Something has to be in the middle, so we draw that thing in the middle, and then we draw the other things around it with space so that you can fill in electrons. Okay, then you put 2 electrons in between the atoms, each one where there's space. Right? So if I have nitrogen and I say my compound is NH3, well, I have a total of 4 atoms there, right? I have nitrogen and 3 hydrogens, so I'm going to put N, and then just because I don't really know the structure, I'm a newbie, I'm going to put space. I'm going to space it out like that because I'm a newbie. I haven't done this before. Then I go and say, all right, nitrogen has 5 valence and every hydrogen has 1. So when I count up, I have a total of 8 electrons to place. So I am going to put 2 electrons here, 2 electrons here, 2 electrons there. Because 2 electrons equal 1 bond. 1 shear pair. Right? Remember that. Now I gotta say, well, that's 2, 4, 6 minus 6. I only have 2 extra. I have no place to put them. I put them on the center atom. I'm going to redraw this neatly now because I'm going to learn in 2 days that the geometry makes it look like this. Because I have 4 sets of electrons. So we call that 4 domains. Because there's 4 sets. 3 bonding. Because remember, these are bonding. That bond, that's a bond, that's a bond. 1 non-bonding. And that tells me its shape. We're going to learn all of that. We're going to start by doing the Lewis dots. But this is our ultimate goal, being able to do all of that. So then anything that isn't shared goes on, that's like this one, goes on the center atom. And then if you don't have an octet where there should be, you have to make an octet by sharing double, triple bonds. And then if you have any extra ones, so let's say 7 and 8 won't happen at the same time, right? Yeah, well, not really. There is an exception I can think of, and we'll do it in class. But usually if you have 7, then you're not going to have 8. And then this holds true even here. You can make polyatomic ions with covalent bonds. So you can make an ion, you better put a bracket and a charge. This is uber important when it comes to polyatomic ions. So down below, I'm going to close out of this and open a new snip where I go down like this. There's a whole bunch of ones that are here. Okay, copy these down, copy this information down. I'm going to go to my little whiteboard and I'm going to do a bunch of these. Right, so you can get a handle of it. I think I'm just going to go with a single color, guys. Even though I like that multicolor, I'm going to go with a single color. Alrighty. So this is going to be covalent. Carbon with any 4 things is very common to be drawn. The thing we have to realize is that, wait, let's not do that. Okay, carbon is special. So special. Carbon can do this thing called hybridizing. We're going to talk about it a lot more probably next week. So carbon starts out like this. You can just listen for now. And carbon goes, oh, you've been such a good little electron. We're going to promote you to your own house. You don't have to share anymore. So you're going to come over here and you're going to go up into the p orbital. And now carbon becomes this. And you can make 4 bonds. Okay, it is the basis for organic chemistry. Life. We are organic. We consist of carbon. This is why we consist of carbon, because little old carbon is a really nice boss and promotes one of its electrons. Okay, now just keep that in mind. So this is a keep in mind for later use. Now let's look at things like carbon with any 4 things around it. Carbon's going to be in the center. So let's do a Lewis dot. In your notes it's CF4. We're going to do CCl4. So carbon has 4 valence electrons. Chlorine each has 7 valence electrons. But I have 4 chlorines. So my total number of valence electrons are 4 electrons plus 7 times 4, that's 28. Okay? 28 plus 4, well, I should say this is 28. Will give me 32. When I go to do this drawing, I must have a total of 32. Always count electrons when you're done. Make sure they equal what they should. Make sure this number equals your predicted number, whatever that predicted number may be. In this case, it's 32. So I'm going to put carbon, and then I'm going to come along and draw my 4 chlorines around the carbon, leaving space. Then I'm going to fill in a shared pair. Okay. Now I have to complete the octet. I'm not doing this according to order. I'm just saying, okay, chlorine likes to have 8 electrons. So I'm going to give chlorine 8 electrons. right? There's 2 that are shared and 6 that are from its outer shell that it already has. So between these 2, chlorine has 8 electrons. So it's happy. So now I'm going to count 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I have 32 electrons, so I am done. Each thing that wants an octet has an octet. Right? Carbon wants an octet, has an octet, right? Carbon's got its own one and the one shared with the chlorine. I put them in from the other one, but these are 8 shared electrons. Chlorine brings 4 to the bond. Carbon brings 4, and chlorine brings the empty space. And that's what this guy does, empty spaces, and he matches up empty space. But if you draw this stepwise, you'll never get your structures wrong. Okay, so that's CCl4. Same thing can go, if I want to do CH4, the difference is I have 4 valence from chlorine plus 4 times 1 from hydrogen. I have a total of 8 valence. Now I put hydrogens around. Oh, look at that. If I count up 2, 4, 6, 8, count that up, I've got my 8 electrons. Please note, hydrogen only needs 2 electrons to be happy. So when you go to do these, things to keep in mind. H only wants 2 electrons. Does not have an octet. Fluorine, chlorine, bromine, iodine. Okay, need an octet. Make sure you draw the electrons on the outside. Don't skip those. If you skip them, your drawing's wrong. Oops, present. Oxygen makes double bonds. Wants an octet, but can share more than one pair. Nitrogen can make triple bonds. Doesn't mean it always have to. It can make them. It can use that function to complete its octet. They like octets. Nitrogen has an exception every once in a while, but they like octets. Carbon can make single, double, or triple if necessary. You can have carbon double bonded to an oxygen like this, and oxygen will have lone pairs like that. That's common for oxygen. Oxygen can also be between things, but oxygen makes at least 2 bonds with 2 low pairs, or makes double bonds with lone pairs. So oxygen can have lone pairs. Generally, oxygen just likes to make 2 bonds. They like to make 2 bonds and 2 lone pairs. Lone pairs mean they're not involved in bonds. Okay, so that's just something to keep in mind when you go to do these structures. Okay, let's look at, again, if you don't have all of this down, pause it, write it on your spiral notebook so you've got your information. Let's look at nitrogen. Let's look at N2. N2 is a popular thing they talk about all the time. So when we look at N2, and we're going to do the Lewis dot for N2, each nitrogen has 5 electrons. Times 2, I'm going to have 10 electrons total in the drawing. So I have nitrogen and nitrogen, because I only have 2. I'm going to put a lone pair here. That's my shared pair, right? So you do a shared pair first. Okay. Now I'm going to complete the octet. I'm not going to complete it at both. I pick one and I complete it. And then I see how many electrons I have left. So let me complete this. I'm going to fill in its electrons. So I have 2, 4, 6, 8 electrons now. So I need 2 more. So I'm just going to, for now, here's what I'm starting with, and I need 2 more electrons. Well, I'm not going to put the electrons on the guy on the right, because he's got an octet. So I'm going to put the electrons here. Now we ask the question, are both of them happy? And you might go, what do you mean by that? Do they both have an octet? So hopefully you come to the fact that, no, they don't. Because this baby doesn't have an octet. So this little friend of his twin, goes, I'm sorry you don't have an octet. I'm going to give you a pair. So he donates a pair. And now there's 2 pairs in the middle. Pair out here, pair down there, pair out here. And then they count. 2, 4, 6. And this one's still not happy. And this guy's happy, so he goes, oh, I have a wealth. I'm going to donate some more. Now you have to be careful. This is where you have to be careful. When you go to draw these, there's 3 pairs in between. And you draw it like this. Because remember, each one of those little dots, this and this, means a bond. So you don't draw it like this. That's a no-no. Because 3 electrons don't make a bond. And your bonds don't go up and down. They go side to side with this. So I have my 2 lone pairs. So this is equivalent to a triple bond in between the nitrogens. And you need to know nitrogen's triple bonded. If you cannot go through this process, you memorize this. If you cannot go through the process. Oxygen's another one. Woo! My computer's flipping out there for a minute. Okay. So we're going to practice some of these. I'm going to stop my